Euler's Method and Logistics Worksheet by Maggie, Angie, Pratik, and Joeseph. So the first one, we have dy dx equals x plus 2 over y with an initial condition of y of 1 equals 7. Approximate y of 4 using Euler's method 3 times. We're going to start off by plugging in x equals 1 into dy dx to get our slope 3 over 7. And then we plug in our points and slope into point-slope form, which is y minus 7 equals 3 over 7 times x minus 1. We plug in x equals 2 and we should get y equals 57 over 7. Then we plug in x equals 2 into dy dx and we get 7 over 13. Then we plug it into our point slope form, which is y minus 52 over 7 equals 7 over 13 times x minus 2. We plug in x equals 3 and we should get 52 over 7 plus 7 over 13 equals 725 over 91. To get that, since this is a calculator problem, we can just plug in it into our calculator and we get decimals, but then you just convert your answer into fraction form, which is just 725 over 91. Then we have the third step, dy dx equals x equals 3, to get our slope again, which is 91 over 145. I plugged that into my calculator and I got that. Then I plugged it into the point slope form again, which is y minus 725 over 91 equals 91 over 145 times x minus 3. I plugged in x equals 4, and you should get 725 over 91 plus 91 over 145 equals 113,406 over 13,195. I tried to plug it into my calculator and convert to fraction, but it didn't work, so I had to do it the old-fashioned way and just solve it by hand. So number 2, we have dp over dt equals p over 60 times 1 minus p over 800,000. So part A, if p of 0 equals 16, what is the limit as t approaches infinity of p of t? So for the first one, looking at the differential equation, we see that 800,000 is the carrying capacity. So limit of t approaches infinity, p of t is 800,000 because it is the carrying capacity. And the carrying capacity is usually the limit as t approaches infinity. Part B, if p of 0 equals 10 million, what is the limit as t approaches infinity of p of t? Explain your answer. So for part B, we have to do the same thing for part A. The limit as t approaches infinity is just going to be 800,000 because it's the carrying capacity. Except this time the graph would look like a decline from 10 million to 800,000. So meaning people would die. If p of 0 equals 16, what is the limit as t approaches infinity of p prime of t? Explain your answer using a graph. So as you can see my graph right there of p of t, as t approaches infinity, it just levels off and becomes 800,000. And the slope of the tangent, which is the derivative, gets closer and closer to 0 as t approaches infinity. So basically, our limit as t approaches infinity of p prime of t is 0. If p of 0 equals 16, for what value of p is the population growing the fastest at, and why? So to find the population growing the fastest, it's just half of the carrying capacity. So population grows fastest at p equals 400,000 because it's half of the carrying capacity, which is 800,000. For the original equation, find p of t if p of 0 equals 16. So we know p of t equals big K over 1 minus a e time to the power of little k times t. Our big K, which is carrying capacity, we know is 800,000, and little k equals 1 over 60 from our dp dt equation. And a, which is just big K minus initial population over initial population, which is 800,000 minus 16 over 16 equals 49,999. So we just plug it into our formula, which is p of t equals 800,000 over 1 minus 49,999 times e to the power of negative 1 over 60 times t. For number 3, we have dp over dt equals 2p times 1 minus p over 100. So for part A, solve for p of t if p of 0 equals 2. So we have our formula p of t equals big K over 1 plus a times e to the power of negative kt, that should be a plus, not a minus. And then we know that our 100 is our big K and our 2 is our little k. So we have our a formula, which is 100 minus 2 over 2, which is equal to 49. Then we have P of t equals 100 over 1 plus 49 times e to the power of negative 2t. And that's our answer. Supposing that only 2 people know the rumor at first, how many days will it take for the rumor to spread to half of the people in the workplace? So the first way we can solve this is by plugging P of t into our graphing calculator, and then y equals 50, because that's half of our carrying capacity, and it asks for half of the people in the workplace. And then using our calculation button on our graphing calculator, we get the point of intersection, which is 1.94591, and that's the amount of days it will take to spread the rumor. The second way we can solve this is by setting 50 equal to 100 over 1 plus 49 times e to the power of negative 2t, and then just solving for t by using our algebra. And we should get the same answer, which is just t equals 1.94541 days. Part C. Again, supposing that only 2 people know originally, but also that if 80 people know about the rumor, then the person will get fired, how long do they have to pack their desk? So the same thing again. The first way you can just plug in P of t and y equals 80, which is the amount of people, and then using the calculation button, finding the point of intersection, which is just t equals 2.63906 days. Or the second way, we can set 80 equal to 100 over 1 plus 49 times e to the power of negative 2t, and then solve for t, which is the same answer. For number 4, we have dy over dx equals x squared minus 7y, with an initial condition of y of 2 equals 3. Approximate y of 0 using Euler's method 4 times. So we're going to start off with dy over dx and plug in x equals 2 to get our slope, negative 17, and then plug that into our point slope form, which is y minus 3 equals negative 17 times x minus 2, and plug in x equals 3 over 2. We're going to use the same Euler's method to approximate y over 0, but this problem's a little different because instead of going intervals up, we're going to go intervals down, but that doesn't change our process of solving for y of 0. After repeating the Euler's method 4 times, and after a bunch of calculations, you should get y of 0 equals 32,729 over 32. So for number 5, dp over dt equals p over 5 times 1 minus p over 12. If p of 0 equals 3, what is the limit as t approaches infinity of p of t? So we know that 12 is our carrying capacity, so if the t approaches infinity, p of t has to equal 12. And then for the second one, p of 0 equals 20, what is the limit as t approaches infinity for p of t? Again, it's just our carrying capacity, which is just 12. If p of 0 equals 3, for what value of p is the population growing the fastest? To find this, we just have to take half of the carrying capacity, which is just 6. Next problem, we have dy dt equals y over 5 times 1 minus t over 12. Find y of t if y of 0 equals 3. So for this problem, we're just going to integrate the dy dt to find y of t. So we have integral of 1 over y dy equals integral of 1/5 times 1 minus t over 12 dt. And we find the antiderivative of both, and then we have k e to the power of t over 5 minus t squared over 120. And using 0, 3, we get k equals 3, so our final answer is y of t equals 3 times e to the power of t over 2 minus t squared over 120. And then part D, what is the limit as t approaches infinity of y of t? So for this one, limit as t approaches infinity of y of t is just 0. And for the last one, number 6, graph the slope field for dy dx equals y over 2 with the initial condition that y of 3 equals 4. So I graphed this on Desmos and I got that. As you can see, I have my initial condition 3, 4. And then for part A, it asks us to use Euler's method to approximate y of 4 using 2 increments of 0.5. We'll start off with dy dx and plugging in x equals 3 to get our slope, which is 2, and then plug that into point slope form, and we get y minus 4 equals 2 times x minus 3, and plug in x equals 3.5. Our answer should be y equals 5, and then the second step we do is dy dx, plugging in x equals 3.5. If we plug that into our point slope form, we should get y minus 3.5 equals 2.5 times x minus 3.5, and plug in x equals 4. Our answer should be y of 4 equals 19 over 4. For part B, use Euler's method to approximate y of 15 over 4 using 3 increments of 0.25. So we have dy dx plugging in x equals 3 and our slope is 2. We should get y minus 4 equals 2 times x minus 3, and then plug in x equals 13 over 4. And then we have y equals 9 over 2. And then we do our second step, dy dx, x equals 13 over 4. And we have that point slope form, y minus 9 over 2 equal to 9 over 4 times x minus 13 over 4. And you repeat this 2 more times because it asks for, or sorry, 1 more time because it asks for 3 increments. The trick to not messing up Euler's method is just to stay organized and be careful with your small little calculations. And our final answer should be y of 15 over 4 equals 729 over 128. Thanks for watching. I hope you enjoyed this video and found it really useful.